we'll be ready to go. Okay, we are now recording, and we're in Chapter 1, Functions in the Graphs. We finished 1.7 last time and started 1.8. And we're just about getting close to the middle of the page on page 76 in section 1.8. 1.8 is dealing with combinations of functions, and then they put a colon there. It should be a semicolon or a comma or something else, because a completely different issue is composite functions. So we're doing the combination of functions first, and then later we'll do composite functions. They're two completely different animals. It's not like composite functions are a subset of combination. They're different animals. So we talked about last time that what are the operations? Oh, here comes Janae. Let me get Janae in here. So Janae East is right there. Okay, first part of the alphabet is doing quite well here, filling up fast. Okay, in fact, we don't have anyone missing until we get down to Chance Henry. But the bottom part of the alphabet's a little spotty, so you need to get your folks there. Bottom part. Okay. All right. So, just like in numbers, you did arithmetic operations, adding, subtracting, multiplying, dividing. Same thing goes with functions. You can add them, subtract them, multiply, and divide them. Only thing you have to watch out for, the main thing you have to watch out for, is that division. Make sure that no value of that denominator function can ever be 0. That's the only new thing you have to do. When you're dividing numbers, you know whether that number denominator is 0 or not. When you're dividing functions, you've got to make sure no value of the function is 0. So the domain of the arithmetic combination of functions, f and g. Okay, here's another issue. I sort of understated the other thing. Okay, so let's say we've got a function f, and its domain is over here, say from -10 to +3. Okay, and then you got a function g. Okay, well, g may go from -5 to 14. Okay, well, when you do an arithmetic combination, you have to have the final, that produces a new function. Adding two functions produces a new function, or subtracting or multiplying, okay, produces a new function. Well, that new function would be between -5 and 3. That would be because the first one was -10 to 3, the other was, or whatever I said, -5 to 14. Well, you have to restrict your domain of the combination function to what's common to both, common to the domains of f and g. So if the f and g have different domains, you have to find what's common. Now, if f and g have completely different domains and nothing in common, you can't do the operation. You cannot do that combination. But in the special case of quotients, all that applies, but you have the further restriction that that denominator, even though 0 may a value for x that produces a 0 is perfectly fine in the domain of g, you have to exclude it if it produces 0. The g of x cannot be 0. Okay, a lot of blah blah blahs. Here are your summary of what we're talking about, if I can get the screen to advance. Okay, sum, difference, product, and quotient functions. Let f and g be two functions with overlapping domains. They've got something in common. We can't have those that have nothing in common. They have some overlapping domain. Then for all the x's that are common to both domains, the sum, difference, product, and quotient functions are defined as follows. The sum function, f plus g of x, that's simply f of x plus g of x. Okay, I mean, it's that simple. Okay, you just add the two functions together. That's what this suggests. That's what this is saying do. Difference function, f minus g of x, That's going to be f of x minus g of x. Now here you have to watch out, okay? Domains are okay, but be sure that you put that g of x in parentheses here and make sure you negate every term in g, okay? Especially if it's a polynomial function. The product function, fg of x, is just f of x times g of x, just what you would expect. And the quotient function, f divided by g of x, is f of x divided by g of x, as long as g of x is not equal to 0. As soon as you write that down, you say that denominator can't be 0, then you figure out what values of x would make it 0, exclude those values. Everything else that's in common with the two domains is fine, but anything that makes g 0, you have to exclude. Now that's blah, blah, blah. That is a lot of letters on a page. Let's see if we're ready for the first example. And folks, this is pretty easy stuff, okay? It seems like to me, and it seems like students get it, but because it's sort of early in the thing, when it comes test time, it seems like it flies the coop. So don't let this happen. Practice on these things. Make sure that you got them down, okay? So here they have f of x, if I can find my pen, is equal to 2x plus 1. G of x is equal to x squared, wherever the x squared plus 2x minus 1. Find f plus g of x. Well, we know from the previous thing that the f plus g of x is equal to just what you would expect, f of x plus g of x. Question? Okay, someone's microphone came on, so I thought maybe you had a question. So plug in what f of x is. F of x is 2. Oh, here comes PC, and if I'm not wrong, that's Shamari, right? Does anyone recall? All right. Is that Shamari coming in? Okay, I thought so. Okay. We're on in Chapter 1, Functions in the Graph, Section 1.8, Combinations of Functions and Composite Functions. And we're on Example 1, bottom of page 76. Okay, and what we're doing is addition combination. F plus g of x, and that's simply f of x plus g of x. Here's your f of x, 2x plus 1 plus x squared plus 2x minus 1. Now, maybe for teaching purposes or just to emphasize, oops, here comes Tamia. So let me get her in here. All right. Okay, Tamia is here. All right, bottom part of the alphabet comes charging back now, okay? They're trying to catch up. Okay. Now, if it helps you, you can put f of x in parentheses here and put g of x in parentheses there. But when you're adding, it doesn't matter. This first set of parentheses is basically totally useless because there's nothing in front of it, so you're just doing those digits. Since the plus sign's in front of this, nothing's changing here either. So I just assume for addition purposes, leave it off. Subtraction, you got to have it, especially on that second term. We'll get there in a minute. Okay? So let's add these two together. We're adding polynomials is adding like terms. The only squared term is that one, so it's x squared. You've got two linear terms, a 2x plus 2x, that's going to be plus 4x. And then we have a constant term, plus 1 minus 1, that adds to 0. There's the sum function right there. X squared plus 4x. Done. Now, it says then evaluate that sum when x is equal to 3. So the sum function f plus g of 3 would be, plug in a 3. 3 squared plus 4 times 3. Everywhere you see an x here, plug in a 3 there. Okay? What does that give you? Gives you 9 plus 12 is equal to 21. Okay? Now, let me show you something. This isn't in the book, but it's something worth noting. What is f of 3? Well, f of 3 would be 2 times 3 plus 1, which would be 6 plus 1 equal 7. Well, what's g of 3? There it is. G of 3 would be, boy, that rhymes, doesn't it? 3 squared plus 2 times 3 minus 1. Well, let's see what that turns out being. 9 plus 6 minus 1, that's 15, minus 1 is 14, and guess what? 7 plus 14, sure enough, is 21. So, you can do it either way. You can first find the sum function, like we did here, and then plug in, or you could have plugged in here and then added the two functions like this. F plus g of 3 would be f of 3 plus g of 3. That's what we just did down here. Both ways it gives you the same answer. Okay, so it may be a nice little way to check your answer. Okay, what I do, I look and see which is easier to do. Okay, if it's easier to combine them first and then plug in. If that's going to be a pain in the neck to combine them, plug them in and then do the operation then. It doesn't matter. That's what this tells you. F plus g of x is f of x plus g of x. So plug in the 3 to this, or plug in the 3 here and add them together. You get the same answer. Does that make sense? I'll put you all to sleep already, okay? Let's see what they do. Now I'm going to erase my slide here, okay, and see what they do. The sum of f and g, just like we did, is f of x plus g of x, and just like we did, and they put it in pink too, okay, 2x plus 1, that's your f, plus x squared plus 2x minus 1, that's your g, and then they didn't show any steps whatsoever, they just went to the answer. But what they did, they combined like terms. Adding, that's what you're doing. X squared plus 4x plus 0. X squared plus 4x. Then they said when x equals 3, you just plug in a 3 everywhere here you see an x. 3 squared plus 4 times 3 is 9 plus 12 is 21. Any questions? Does this make sense? Okay, guess what? There's always a checkpoint right after every example. Please do your checkpoints as soon as you can after class is over. Let's see if they're going to show you example 2. No, they don't. They skip 2, 3, and 4. So let's do those hopefully fairly quickly. But okay, let me just make sure I've got 16 students here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I'm missing somebody. So let me see. Someone's come in that I didn't get marked in the book. Okay. I'm sorry, folks. It's going to take a little bit of time to check this because this puts them alphabetically by their first name, kinda. It just sort of messes all up. Okay, I've got Brianna. Yes, I've got Brianna here. I've got D here. Yep. I've got Ashford here. Yep. I've got Ivan here. Got it? I've got Jakiria here. Got it? I've got Jemiah here. There's Jemiah. Yep, got it. Jakiria, Jemiah. I've got to scroll down. I can't read that. Okay, I've got Kiara here. Got it. I've got Shamari here. I've got Kanisha here. I've got Rosa here. I've got Tamia here. And I've got Terrell here. Going down a little bit further. Okay, Terrell's here. I've got Tommy here. I've got Tyler here. Make sure I've got Tyler. Where did you go, Tyler? There you are. Yep, I've got Tyler here, and I've got Weston here. That should be the right. So I should have 16 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. Oh, actually, I've got more people marked here than I've got. I'm sorry, I had it the wrong way. So evidently somebody was here and had to bump out. Either their internet failed or they had to get off for some other reason. So sorry, that was a waste of time, but I want to make sure I didn't miss anybody. All right, yes. Who is this? Okay, I still couldn't hear the name. James? Oh, are you saying Janae? Oh, Shay. Okay, got it. Okay, I didn't hear the CH. Okay, Shay. Okay. All right, well, good. We'll look forward when she gets here. If you know she gets here and trying to get in, let me know in case I'm missing it. All right, thanks for telling me. All right, so that is example 1 so far. I was talking about the checkpoint. I was just going to go to the whiteboard so we can do example 2. And of course, I've got to do a little bit of adjustment to the whiteboard. One is that this taskbar is in my way. It's covering part of the whiteboard that I can't use. And then y'all can't see it, but I have a list of you over here on the right hand side, so I need to move the whiteboard as far as I can to the left and up so I have as much white space to write on as possible, and that's what I do now. Okay, I think I still need to move it slightly to the left. That's good enough. Okay, so let me get my pen in hand and let's do this one. Tablet. Okay, here's f of x. Example 2, top of page 77. 2x plus 1. Okay, g of x. Is this the same one we had? I think so. Why not? I'll leave it up there. G of x is equal to x squared plus 2x. That's exactly the same one. X squared plus 2x minus 1. Okay? And now it says find f minus g of x. Well, we know what that is, don't we? That is f of x minus g of x. That's what that means. That's a subtraction function. So what we'll do is take the f of x here. I'll put them in parentheses again. 2x plus 1. That doesn't need parentheses, but I'll put them there. Minus g of x. This one definitely needs parentheses. Minus x squared plus 2x minus 1. Okay, so now I'm going to remove the parentheses. For the first one, all I do is get rid of them. That's all. 2x plus 1, because there's nothing in front of it to change it. Here, though, there is a minus sign in front, so I distribute that minus sign across everything there. So that will be a minus x squared, a minus 2x, and minus a minus 1 is a plus 1. Does everybody see that? Why that made a difference here? And now at this point, we combine like terms just like we did before. And if you like, leading off with the maximum exponent, that would be a minus x squared. I just sort of don't like starting off with a negative, but we will. And then here we have plus 2x minus 2x, that goes to 0. But here we have a plus 1, that's plus 2. So there's your difference function, f minus g of x, minus x squared plus 2. I think you see that's what they got in the book. Then it says evaluate that difference when x is equal to 2. So we want to do f minus g at 2, or is it minus 2? I don't remember. I have a good memory. It's just short. That is equal to 2. Okay, so what would that be? Now, this is a pretty good exercise too, though my pen just flew the coop. Where did it go? Pen, where are, oh, there you are. Okay. You take this and do a minus 2 squared plus 2. Now, I didn't write it right, okay? And here's why. What you have to do is make sure you put this in parentheses. The negation sign is in front of the number. And you do your rule of order of operation. Please excuse my dear Aunt Sally. I don't know what she did, but please excuse her. The please means parentheses. Now, we didn't have any parentheses to begin with. I put some in, but forget about that for now. What's excused? Excused is exponents. You exponentiate before you, my dear, is multiply and divide. Aunt Sally is add and subtract. So you exponentiate before you negate or subtract. So this will be a minus 4. You exponentiate that first, plus 2, and that gives you a negative 2. Okay. I've got something on the screen there. I don't know what it is. Well, it must be on the white screen. Okay. And they got negative 2 also. Good for them. There is a checkpoint. Please do the checkpoints. Okay. Any questions on example 2? Okay. Now example 3 are new functions, so I do want to clear the screen. All right. If there's no questions, I'm going to clear. Okay. All right. Example 3. This times your f of x, if I can get my pen to show up, f of x is equal to x squared. Okay, your g of x is equal to x minus 3. Oh, I meant to go on and plug the others in before, but you could go back and do that. And what you're asked to do is find fg of x, the product function, fg of x. Well, we know what that is. That's f of x times g of x. And these are simple polynomials, so that's going to be pretty easy to do. That's going to be x squared, that's your f of x, multiplied by x minus 3, that's your g of x. And to do that operation, you simply distribute. X squared times x is x cubed, and x squared times a minus 3 is minus 3x squared. Done. We found our fg of x. It then says evaluate the product when x is equal to 4. So what we're trying to find is f g of 4. So what do? We plug in everywhere you see an x here, you put a 4. That would be 4 cubed minus 3 times 4 squared. Okay, 4 cubed, 4 times 4 is 16, times another 4 is 64, minus 3 times 16, that's 64, minus 48, and I'm pretty sure that is 16. All right, let's do it the other way. This is a good time. Let's do f of 4. Well, f is x squared, so that'd just be 16. And g of 4, g, what's 4? Okay, that would be 4 minus 3. That's equal to 1. And 16 times 1 is 16. In this case, it was way easier to plug in the x here rather than having to go through all those big powers. Plug them in here, really easy. So that was much easier to do f of 4 times g of 4, which would be 16 times 1 equals 16. So sometimes it's easier to chug and plug, and other times it's easier to plug and chug, whichever makes the most sense for you. Or just use the other one to check your answer. Okay? And again, after example 3, there is a checkpoint. Do it. Now let's do the quotients. So let's clear the screen. Any questions on this before I clear it? Okay. Here's example 4. Find f divided by g of x and g divided by f of x, because those are going to be different animals most of the time. For the functions, f of x equal the square root of x, and g of x is equal to the square root. Okay, my phone's making noise. Now, just because this could be a student, I'm going to pause the recording here and just see if it is a student trying to get in. Like, we'll pause there. If it's something from Minneapolis or somewhere like that, I don't bother. But that was from here in Birmingham, so I thought I'd give it a shot. All right, so g of x was the square root of 4 minus x squared. Oh, yuck. There's these buttons on this pad that, because I'm left-handed, my finger will hit them every now and then when I'm writing near the top. Okay, so now on the surface, this is a very easy thing to do. Okay, however, scratch the surface a little bit and you see there's a little bit more involved with this. Okay, and one reason is because you have square roots here. So here they've thrown in square roots and they've thrown in division in the same example. In fact, they did 2 different divisions. So what you have to do here is, first place, when you write down something like this, see every other function we've done. Example 1, polynomial function, defined everywhere, no mess. Example 2, polynomial functions, defined everywhere, no worry. Example 3, polynomial functions, defined everywhere, no worry. That's why I didn't even bother stopping and saying what's the domain. But here we have square root functions. This matters. Okay, So what we have to do here is determine our domains. And this first one is x has to be greater than or equal to 0, because you can't take the square root of a negative number. So there's a domain. All positive x values, or 0. It can be 0. Over here, what's under the radical? 4 minus x squared. That's got to be greater than or equal to 0. Now that's a whole different ball of worms here, isn't it? I guess you have worms and balls, I don't know. Okay, what in the world is going on here? Now this is sort of convoluted and you might get lost in the sauce. Please try to hang on. What you do with a polynomial, with a quadratic, always see if you can factor. And this one we can. That would be 2 plus x times 2 minus x. And that product has to be greater than or equal to 0. Oh, here comes Ladarius. Okay, so let me let Ladarius in, mark him on the roll. Bottom part of the alphabet is coming in strong now. Okay, still not caught up with the top part, but it is coming in nicely. Okay, Ladarius, if you're here, we're in chapter 1, functions of the graph, section 1.8, combinations of functions and composite functions. We're on page 77, bottom of the page, example 4, finding the quotient of two functions. And here's what they're asking us to do: find, well, if I use the right end of my pen, find f divided by g and g divided by f. They give us f, which is a square root function, which means we have to mess with this domain, and g, and that was simple. G, we have to mess with this domain because it's also a square root function. However, g is a little more complicated because g, what's under the radical, is a product. Now if you remember back when you're multiplying signed numbers, if the two signs are the same, that means it's positive. If the two signs are different, that means it's negative. So we have to make sure that these two are either both plus or both minus. So what we have to say is 2 plus x is either, what you want to do first, greater than or less than? I don't care. Let's do greater than. Greater than or equal to 0, and at the same time 2 minus x has to be greater than or equal to 0. They both either got to be positive or they both got to be negative for this to be true. Well, here we would subtract 2 from both sides. That doesn't mess with your directional inequality. That gives you x is greater than or equal to negative 2. Okay, we can handle that. Over here, there's a couple ways you can do it. If you subtract 2 from both sides, like we just did, that gives us, again, these go out, and you get minus x is greater than or equal to minus 2. Well, we don't want minus x, we want x. So we're going to divide both sides, or multiply both sides, by minus 1. Well, guess what that does? When you add or subtract positive or negative numbers to both sides of a directional inequality, it doesn't change the sign. When you multiply or divide positive numbers by both sides of a directional inequality, that doesn't change the sign. But when you multiply or divide a negative by a negative number, you change the sign. So this becomes a positive x, but you have to flip the inequality because you divided by a negative number. Or you could have multiplied by a negative number, same effect, and this one you get a 2. Okay. Now, that tells you your domain for this function, for the positive values. I like to draw a number line just to show this. Now this is way too much information, but this is what you have to think of. If you did you a number line here, okay? And put a 0 somewhere here and do a 1, 2, 3, 4, a -1, a -2, -3. I didn't leave enough room for a -4. What does this tell you? X has to be greater than or equal to, so it could be equal to a -2 or greater, but at the same time, this is an and here, remember? It has to be less than or equal to 2, so it has to be in here. So anything in between -2 and 2, there's your domain. Now, that's just half the issue. Okay, we've still got to go back and say, what if 2 plus x was less than or equal to 0 and 2 minus x is less than or equal to 0? If they're both negative, your product is going to be positive. Well, from what we did before, this would be x is less than or equal to -2, and this would be doing the same thing we did before. This would be x is greater than or equal to +2. Well, guess what? X can't be both of those. Less than or equal, I'm going to go to a different color here. If I can find my pen, here we go. I'm going to use red if that's okay. Down here, this one says x is less than or equal to -2. This one says x is greater than or equal to +2. Guess what? Nothing in common. There is no domain down there. So this is not what you want. This is what you want. X between, and I'm going to go back and write that in black. Okay, what we just had, your domain for this function is going to be the set of all x's such that, or I'll do a vertical line, -2 is less than or equal to x is less than or equal to +2. That's these right here, from -2 to +2. This was greater than or equal to 0. Well, let me do a different color for that one. Okay, what color you want? Anybody? Give me a color. Not red, not white, not black. Make up a color. Blue. You got a light blue, a medium blue, and a dark blue. Dark. Okay, let's do dark blue. This one is x is greater than or equal to 0. Where's your 0? Anything greater than or equal to 0 are out here. So what is your domain when you're combining these functions? This would be if you're adding them, if you're subtracting them, if you're multiplying or dividing them, you have to be limited to 0 to +2. And that's all, folks. So that's where we're going to start. Okay, so f divided by g, let me go back to black. F divided by g would be simply the square root of x. That's your f divided by the square root of 4 minus x squared. That's your g. That's it, with the understanding that, now here's where you have to come in. You also cannot let 4 minus x squared be 0. What would make that equal to 0? That would be x equal 2 would make that 0. So now we have to exclude the 2. So our domain here, the 0 is fine, but the 2 is not. So you have to put it like that. Okay? Because any other value in this domain, 0 to 2, that's going to be fine, except 2. 2 would make your denominator 0. So that's a parentheses here. This is a bracket here. Let's do this one. That would simply be the square root of 4 minus x squared. That's your g of x, divided by your f of x is the square root of 2, square root of x, okay? Well, here, again, you're limited to that domain between -2 and 2, but, well, no, between 0 and 2. So the domain of the quotient function, or any of your functions, would be domain of the quotient. And I'm going to put the quotient, either one of the quotient function starts off being between 0 and 2. I just got tired of writing set notation, so I'm writing an interval, okay? Except that here, the x can't be 0, because if x was 0, that would give you a 0 in the denominator. So now we have to exclude the 0 by putting a parenthesis there, but you can include the 2 here, so this one has the bracket there. So here, let me see if I can erase that and make it look a little bit better. I can't get it to erase. Why won't it erase? Yuck! It drives me nuts. I erase, and nothing happens. There we go. I got rid of both of them. I'm trying to be 2. This is a parentheses here because 2 is not included. Here the 0 is preceded by a parentheses because you can't have 0 in the denominator. You can't have divide by 0. So this combined everything, okay? It combined your common domains that we had to get from here and here, okay, which gave you the blue as your common domain here. So that would have been true for addition, subtraction, multiplying, dividing. This would have been good, okay? So no, addition, subtraction, multiplying. Where in the world is my pen here? There it is. Nope, there it is. Okay. This would have been a good domain for addition, subtraction, or multiplication. That would have been our domain. For dividing, if you divide f by g, you have to lose the 2. Okay? So you put parentheses there. If you divide by f, that makes you lose the 0. And you do that. Now, not all of them will work out that way, but this one certainly does. Okay? So, this problem emphasized what we mean by common domains. That's what we had to go through there. It also showed what you have to do beyond that. When you're dividing, make sure your denominator is never 0. This would be 0 at plus 2, so you ignore that. This would be 0 at 0, so you have to leave that one off. Does that make sense? Any questions? All right. Let's see how the book did it. They wrote down, this is the easy part, okay? The division, f divided by g is just simply f divided by g. I mean, that's all that it is, folks. And g divided by f is just that. The thing that gets messy here is the domain part, and that's because both of those are square roots, so you have to determine the domain of this one, the domain of this one, and then you have to find out what's in common. This is the common domain, and then you have to find out what you exclude here and what you exclude there. So that's what you go through here. So they did the quotient functions, the easy part, and then they said the domain of f is just what we said here. They wrote it this way, 0 with a bracket all the way to positive infinity. They wrote it in interval notation. This one they wrote basically like we did here. Can't get it here. This in interval notation would be bracket 2 minus 2 minus 2. Yuck! Those minus signs are just so hard to write. This thing will just almost refuses to write a minus sign. Okay, minus 2 to 2. Both brackets. Okay. That was the domain of G. Okay, so the intersection of those two is this one, 0 to 2. It counts to 0 here, but only goes up to 2 there. Okay, and that would have been the domain for your addition, subtraction, multiplication if that had been your problem. That wasn't our problem. Ours was a division problem. So over here, when we look at this one, we see we have to, where is, oh wait, here comes Shay. Wait, yeah, Shay is here. If I could find my cursor to letter N. Okay, so Shay is here. There we go. All right, again, helping the bottom part of the denominator of the alphabet here. Whoa, my pen just took a dive. Okay, let me just, well, I don't know. It's hard to tell. All right, are there any questions on this? I know there were a lot of pieces of that one, but if you see in the book, they go through that as well. Why they chose division to throw all the mess into, I don't know, but you've hit it all now. Okay, there is a checkpoint after example 4. Please look at the checkpoint. Okay, now it looks like there's either a chat or someone's trying to get in. Let me see if someone's trying to get in here. I didn't see the name pop up. Let's see if anyone's trying to get in. Nope, wrong one. No, well, I can't tell. This is such a pain in the neck. Okay, where in the world is my cursor? There it is. Let's go back to the top and see if any, nope, nobody new coming in. Now it says we should have 17 people here. I think more people have been here before. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, we've lost 2 people from the beginning. Sorry about that. Now, was that chat intended for me or for one of the rest of you? Because it really is time consuming and kind of hard to open a chat in the middle of talking. So if you have a question, ask the question, okay? I don't mind being interrupted. If it's a private chat, if I open it up, everybody can see it. So there's nothing private then. So was there anything for me? All right. And let's minimize this. Now let's flip the page to page 78, and we go back to our PowerPoints, and we'll go to resume the slideshow, and next thing we go to is composition of functions. Now this is a new concept, not something that you've run into in earlier math. We've added, we subtracted, we multiplied and divided before. We knew we couldn't divide by 0 before. So all that was kind of new, old stuff. We knew about domains before, maybe only this term, but we've all dealt with those. This is something sort of new. This is the composition of functions. Here's what we mean. Another way of combining 2 functions, now they call this combinations, of 2 functions is to form what we call the composition of one function with the other. Now, here's our example. If I was on the right pad. Okay. F of x is equal to x squared, almost like one we've seen before, and g of x is equal to x plus 1. Now, what do we mean by the composition of f with g? Well, here's what we mean. That's taking the f function, the one that shows up first, write it first, and then in your parentheses, you put the g function. Not x, but g of x. Close that out, and then you do what it says on the inner first. That's f of, well, what is g of x? X plus 1. Okay? So you just plug in what g of x is. Then what you do is look and see, what does the f function tell you to do? It tells you to take what's in the parentheses and square it. Well, now what's in the parentheses is x plus 1, so now we take x plus 1 and square it. That's what we mean by composition, composing one function with another. That composition is denoted as F composed with G, and that's exactly how it reads, F composed with G. You can also say the composite of F with G. Here's how I like to read it because that gives me good insight. I say this says F of G. Now that's not an O, but I can imagine it is. F of G. Well, that's exactly what we did here, wasn't it? F of G of X. So that's why I like to read it. Actually, it's F composed with G, or the composition of F with G, but you can also think of it as F of G of X, or whatever your variable is. Okay, so here's your definition of the composition of two functions. Composition function F with the function G is composition of F with G of X would be F of G of X. F of G of X. Now, I just had this pop up. It looked like somebody else left. Sorry about that. Okay, I am recording. Hopefully this will get out there for everybody. So now that's what we mean by this, but now we have to stop and think, what is our domain? The domain of F of G of X is a set of all the x's in the domain of G, because you see the x is what sets the domain. Well, everything in the domain of G such that the G of X is in the domain of F, because the range of G is what you're operating on with the F function. Okay, so here's your diagram of that. If you start with some domain of F of G, the composition of F with G, also G, this is where you pull your values from to operate with G. So G operates on that and gives you a G of X. Well, then F doesn't come back here. It takes the result of G of X, the output of G of X, as the input for F, that's what this shows, and that gives you the output for F. Or looking at it the other way, F of G of X takes the X from here, and F of G operates on that and gives you F of G of X there. Okay, I don't know if this is helpful. Once you know what you're talking about, it makes sense. Whether you're seeing it for the first time, it makes any sense or not. But just notice, F is operating on the output of G of X, the range of G. So you first have to decide what x's can be in the domain of G, and then what ranges of G can be in the domain of F. So you got those two questions to deal with. Most of the time it's pretty obvious. Okay, so here we have two functions. This is example 5, middle part of page 78. Here's our F function. F of X is equal to X plus 2. G of X is 4 minus X squared. So it says find the following. Okay, what is F of G of X? Well, by the definition, that was, and that's why I said it this way, F of G of X, close parentheses. Okay, always, oh, and close that parentheses too. Close them both. Now, always start with the innermost function first. Just write down the F of, and what was your G? 4 minus X squared. Okay, now that's what you're operating on with the F. What did the F function say? Take what's in the parentheses here and add 2 to it. So we'll take what's in parentheses there, 4 minus X squared, and add 2 to it. Right? So that's going to be 6 minus X squared. There's your composite F composed with G of X. Okay? Now, let's do it the other way. G of F of X. Well, what does that mean? G of F of X. Close, close. Well, you put the innermost part in first, so you leave the G alone for now. G of x plus 2. That's what the f is. Okay, right? You just write that in. Okay, now what does G tell you to do? G says start with the number 4 and subtract from that whatever's in this parentheses squared. What's in the parentheses is x plus 2, and we're going to square it. Okay, that's going to take a little bit of work. 4 minus. Now, I don't know if you remember the easy way to do square a binomial. Square the first term, x squared, plus twice the product of the two terms. 2 times 2x would be plus 4x, and then square the last term plus 4. Okay, so got a little bit of work to do. This will be 4 minus x squared. You got to distribute this minus sign across everything. Minus 4x minus 4, and you notice plus 4 minus 4 adds a 0, and you wind up with minus x squared minus 4x. Now just a note, f of g of x is not equal to g of f of x most of the time. There are a few occasions when they will be equal, and when they are and they're equal to a special thing, that makes them very special functions. These are not. Okay, these are not special functions. They're composites, are not commutative. Now what they ask for next is this. If I could get my pen to show up. Where are you, pen? There you are. Okay. What is g of f of negative 2? So g of f of negative 2 would be g of f of x, but you multiply in there, you put in there a negative 2. So this would be, now this minus sign is there. Okay. Then the negative 2 is in parentheses, negative 2 squared. Okay, minus 4 times, and that x is negative 2. Okay, be careful with that, folks. Okay, so let's do it. It's a minus. Do the parentheses first. Please excuse my dear Aunt Sally. Negative 2 squared is positive 4, but this minus makes it a minus 4. Then a minus times a minus is plus 8, and when you add those together you get a positive 4. Now again, I'm going to show you another way to do this. If you recall, this is g of f of negative 2. So what we'll do first is g of. Now what is f? F is negative 2 plus 2. That's 0. And then you say, what is g of 0? G of 0, plug in a 0 for x, and you get 4. Oh my goodness, that was so much easier than doing it the other way. But sometimes it's not. Sometimes it's far easier to do the composite first and then plug in. Other times it's easier to plug in and then do the composite. Whatever works best. But it's a good way to check too. And by the way, f composed with g of negative 2 is going to give you a very different answer. You would just plug that in here, and that would have been a, if I could get my pen to show up, 6 minus a negative 2 squared. Well, negative 2 squared is 4. 6 minus 4 is 2. So very different answers. Composite functions do not commute. You can't change the order and get the same answer, except in very special circumstances. Any questions before I erase the slide? Okay, well, I'll erase the slide and let's watch how they do it. The composition of f with g is, just like we said, f composed with g of x, or f of g of x is f of g of x. Okay, that's how I like to think of it. Plug in the g first. There's the g, so that's going to be f of 4 minus x squared. And that's exactly what they do. They plug in what G is here in the parentheses. Now, we take the F function and operate on this. F is defined for X. It says whatever's in the parentheses, take it, add 2 to it. So we're going to take this 4 minus x squared and add 2 to it. That gives you minus x squared plus 6. I said 6 minus x squared. It doesn't matter which way you write it. Same answer. Now, if you were doing WebAssign and you put 6 minus x squared and they wanted to see minus x squared plus 6, they would tell you that's a wrong answer. It's not a wrong answer. It's just in a different form. Okay? That's one of my pet peeves with WebAssign. They're looking for one and only one answer, and there's sometimes several ways you can give correct answers. Both of those are correct. It would tell you one of them was wrong. You think you did something wrong, you didn't. You just didn't give it in the form they wanted. So you get used to trying different forms and then say, oh yeah, okay, that one works. Okay, if you have enough time to do it. Okay, so there's the A part. Any questions on that? The B part then says the composition of G with F would be G of f of x. So now we put the f of x inside here, and that was your x plus 2. G operating on x plus 2 says you take the number 4 and subtract what's in the parentheses squared. Okay, so that would be 4 minus x plus 2 squared. Now I meant to tell you this. I told you the shortcut. If you don't remember the shortcut, you can do it this way. What x minus or x plus 2 squared means is x plus 2. To square anything is to multiply it by itself. X plus 2. That's what x plus 2 squared means. Now you FOIL that. X times x is x squared. That's the square of the first term. Then the outer says plus 2x. And the inner is plus 2x. And finally the last is plus 4. Well, what have we got here? The first one squared, x squared, twice the product of the two, plus 4x, plus the square of the last term, plus 4. So it gives you the same answer. If you don't remember the shortcut, you can always multiply them together and FOIL them, okay, if they're binomials. So this will be 4 minus what we just found out, x squared plus 4x minus plus 4, and then distribute that minus sign across the parentheses, and the 4 minus 4 add to 0. The other negatives here are that. Note in this case, and I will say in most cases, f of g of x is not going to equal g of f of x. Just not going to happen. There are a few cases that will happen. Those are special cases that we're going to be paying attention to a little bit later. Okay? Now, the third part says to use the result of part B and do f of g of negative 2. Well, remember we said f of g of x was minus x squared minus 4x. So you put the minus here, the negative 2 squared minus 4 times the negative 2. Well, again, do the exponent before you negate. Treat that as a subtraction. So it would be a minus 4, and then minus times minus is plus 8, and that gives you a plus 4. Now, I turned around and showed you if you had done the evaluating the functions first, then done the composite, that would have been even easier. But you never can tell that until you do it. Okay. Now, in example 5 that we just did, actually we need to do example 6 first. How are we doing on time? Oh my goodness. Have we just gone over? I'm afraid we have. Right? Sorry about that, folks. But there'll be no extra charge. We will start next time with example 6, the top of page 79. let me give you some homework exercises to work on. Oh, we almost finished 1-8. You can do number 3. You can do any of the odds 5 through 11. Oh, number 3 is a calc chat if you need to see how to get the worked out solution. 5 through 11 are at calc chat. 11's at calc view, so you can see a full-fledged interactive version. Any of the odds 13 to 23, they're all at calc chat. 13's at calc view. 25 or 27 are both at calc chat. 25's at calc view. And then you can start doing some of the odds 29 through 33. They're all at calc chat. 33's at calc view. Now if some of those get a little tough toward the end, hang on to them. We can work some more of those after we do example 6. Any questions? All right. Have yourself a good weekend. Now it's going to be a rainy weekend, I think. The hurricane's supposed to hit somewhere. I haven't heard lately, but it's could be pretty bad. So sounds like a great weekend to be inside, working on your research papers, working on your first test, and working on homework exercises. Boy, pre-calculus algebra will take care of you on it. Okay, give you plenty to do on a rainy weekend. The main thing is be safe, be careful, take care. Any last questions before I'm going to go on and stop sharing? But before I end the meetings, are there any questions? And who is this? Oh, Shay? Yeah, I got you. Shamari told me you would be coming in, and we were watching for you. You popped up. I got you on the roll before you got here. So you were in the waiting room trying to get hooked up, and I got you. But thanks for asking. Good idea to ask. Any other issues? All right. Then I'm going to go on and end the meeting, and we will see you on Tuesday. Okay? Good deal. And by the way, over the weekend is midterm, so we've all finished half of the class. Whoa, we got some moving to do to get everything covered, but we're making progress now. So yes, there's a research paper due by the end of the term. I prefer you to get it in earlier than later. It's all out there on, if you go to week 1 under instructional materials, and look there, you'll see the research paper, general instructions or something like that. Tells you everything. If you go to the first day of class, now we didn't have Screencast-O-Matic working then because the school forgot to pay the bill or didn't pay her bill or whatever. So, but you go back to last spring term, I go through it for them. So it's on the first day of class. It probably says syllabus, or maybe the second day of class if it says research paper, but you can find it there. You can hear me talk about it. It's out there on a link under instructional materials for week 1, and also the link for your YouTube videos is there under week 1 as well. It says no, there's just one research paper for the course. Have you already done it? Well, I don't. Okay, let me see if you have turned it in. I don't have one here for you. Jemiah has turned one in, but I don't think I have one for you yet. The only person that has a grade on the research paper is Kanisha, and then I have Jemiah's that came in. I haven't had a chance to grade, but those are the only two. You gave me the topic for the research paper. Maybe that's what you're thinking of. Yes, you turned in the topic, but I don't think you turned in the paper. Now maybe you did it, but you haven't turned it in yet, or at least I haven't found it. Okay? All right. Good question. Any others? All right. Good deal. We'll end the meeting. Have a good but safe weekend, productive weekend working on pre-calculus. Okay? Take care. Bye-bye.